Greetings, math students, from Mrs. Marcellus and my good friend Gottlieb. Today we're going to learn to generate equivalent expressions. Today's learning objective is students will write equivalent algebraic expressions and will determine if given algebraic expressions are equivalent. Today's vocabulary word is distributive property. The distributive property says, multiplying a number by a sum or difference of two or more terms is equivalent to first multiplying that number by each term in the sum or difference individually and then combining the results. You said you're a little confused, Gottlieb? That's kind of hard to understand. Yeah, I agree. Perhaps looking at an example or two will help us. Let's break down the definition with the first example. It says multiplying a number by a sum or difference of two or more terms is equivalent or equal to. Let's stop there. The first part says we would combine the 7 minus 4, which gives us 3, and multiply by 2. We're multiplying a number by the result, or the sum or difference of two or more terms. And this gives us 6. Then this is going to be equal to first multiplying that number, which is the 2, times each term in the sum or difference individually. This means we'd multiply the 2 times the 7 and the 2 times the 4. And you can see that is on the right of the equal sign. 2 times 7 is 14, and 2 times 4 is 8. If we subtract 14 minus 8, which is combining the results, we also end up with an answer of 6. Either way you approach it, you get an equivalent result. This also applies to algebraic expressions. We could either combine x plus 9 and multiply it by 5, or multiply 5 by x and multiply 5 by 9, and the results will be equivalent. This will give us 5x plus 45. If we wanted to prove this was true, we could assign a value to x. I'm just going to say x equals 3. I'm just picking a random number. And I can now solve for inside the parentheses. That would be 5 times 3 plus 9, which is 12. And that would equal 60. If I plug x equals 3 into the other expression, I would have 5 times 3, or 15, plus the 5 times 9, which is 45, which also equals 60. The distributive property allows us to generate equivalent expressions. What do you say, Gottlieb? Do you think we should try some examples? In our first example, we will write an expression that is equivalent to 3 times the quantity x plus 3. Since we don't know what x is equal to, we cannot solve x plus 3 inside the parentheses. One way you could write an equivalent expression is to do repeated addition. We have 3 times x plus 3. We could write x plus 3 plus x plus 3 plus x plus 3 and figure out what the total would be. We would have 3 x's all together, and we would have 9. And our equivalent expression would be 3x plus 9. However, we probably don't want to do repeated addition because it's a lot of work to write all that out. Instead, we can apply the distributive property to generate our equivalent expression. We do this by multiplying the number on the outside of the parentheses times each value on the inside of the parentheses. I also want to note that when you have a variable that is by itself, such as the x, the coefficient of this variable is actually 1. We don't write the 1 though because it's not necessary. 1 times x equals x. Therefore, the 1 isn't needed. Now, back to our distributive property. We would multiply 3 times 1x, and if it makes you more comfortable, you can write the 1 in front of the x, just to be absolutely clear that you are multiplying 3 times 1, and that gives us 3x. We also multiply 3 times 3, which gives us 9. Our equivalent expression is 3x plus 9. In this example, we will multiply 8 times the quantity 2m minus 3n. Even though we have two variables and it is subtraction inside the parentheses, the distributive property works the same. We will multiply 8 times each term inside the parentheses to get our equivalent expression. 8 times 2m is 16m, and 8 times 3n is 24n. Our equivalent expression is 16m minus 24n. In this example, you can see that the constant is on the opposite side of the parentheses. However, this doesn't change anything. If you wanted to, you could move 12 to the other side of the parentheses and write 12 times the quantity 3w plus 1/3. You're allowed to do this because multiplication is commutative. Or in other words, if you switch the order of a multiplication problem, you will still get the same result. We can apply the distributive property either way by multiplying 12 times each term inside the parentheses. And if we multiply 12 times 3w, we'll get 36w, and 12 times 1/3 is 4. If you don't remember how to do that, it looks like this. 12 over 1 times 1/3 will equal 12 over 3. 12 divided by 3 equals 4. You also could have cross-canceled the 12 and the 3. Our equivalent expression is 36w plus 4. We can also write an equivalent expression by factoring an expression. This is essentially applying the distributive property in reverse. We will divide out a common factor and rewrite the expression. In this example, both 35x and 30 have a common factor of 5. To write an equivalent expression, we will divide both 35x and 30 by 5. This is the number that will be on the outside of the parentheses since it was factored out of both terms. On the inside of the parentheses, we will write the results of the division. 35x divided by 5 equals 7x. 30 divided by 5 equals 6. Our equivalent expression is 5 times the quantity, 7x plus 6. We can check our answer by multiplying 5 times the contents of the parentheses. 5 times 7x is 35x, and 5 times 6 is 30, so we know these two expressions are equal. You might choose to write this as a division problem. We could write 35x plus 30 inside a division bracket. We're going to divide both of them by 5, so that will be our divisor. Our quotient will be the contents of the parentheses, 7x plus 6. And we know that when we check a division problem, we multiply the divisor times the quotient, and we should get the dividend, or what was originally inside the division bracket. Whichever method works best for you is what you should use. In this example, we're able to write a couple different equivalent expressions. We want to think of common factors for 4x and 32. One common factor is 2. I could divide 4x by 2 and 32 by 2, and this would leave me with 2 times the quantity, 2x plus 16. However, that's not the only common factor. Both 4x and 32 can be divided by 4. When we divide 4x by 4, we get 1x, or just x, and 32 divided by 4 is 8. A second equivalent expression to 4x plus 32 is 4 times the quantity x plus 8. If we were factoring this to solve some type of algebraic equation, we'd probably want the 4 times the quantity x plus 8 because that's the greatest common factor, but it is important to note that it's not the only equivalent expression. Let's identify the expressions that are equivalent to 8x minus 4. We can either factor the original expression, or we could apply the distributive property to write equivalent expressions for our examples. In the first example, I could multiply 4 times 2x to get 8x, and 4 times 1 to get 4, and we can see that that is equivalent. I also could have factored a 4 from 8x minus 4, and that would have given me 2x minus 1, and that would be a second way to test for equivalency. The expression of 4x is obviously incorrect because in our original expression we have 8x. We're unable to subtract 4 from that because the 4 is not multiplied by x. Our next expression will be equivalent because 2 times 4x is 8x and 2 times 2 is 4. We also could factor out the 2 from our expression to prove this equivalency. 8x divided by 2 is 4x, and 4 divided by 2 is 2. Our final expression is also equivalent because 8 times x is 8x, and 8 times 1/2 is 4. If we wanted to, we could also prove equivalency by factoring. 8x divided by 8 would be 1x. 4 divided by 8, or 4 over 8, is 1/2. About 8.9 million metric tons of goat milk are produced in Asia each year. About million metric tons are produced in Africa each year. Write 2 equivalent expressions that can be used to calculate the total amount of milk produced on these 2 continents in 5 years. First, we need to determine the information we need to write the equivalent expressions. We will need that there are 8.9 million metric tons of goat milk produced in Asia and million metric tons produced in Africa each year. Also important is we want the total combined milk production on these 2 continents for 5 years. One way we could approach this is to add together the amount of milk produced in Asia and the amount of milk produced in Africa together first, and then multiply all of that times 5. Since we don't know the amount produced in Africa, we can't go any further than this. A second way we could approach this is to multiply 5 times the amount produced on each continent individually, and then add those 2 amounts together. We would have 5 times 8.9 million plus 5 times m. We can simplify this somewhat by multiplying 5 times 8.9, which is 44.5. We can also write 5 times m simply as 5m. The expression 5 times the quantity 8.9 plus m is equivalent to 44.5 plus 5m. Wow, Gottlieb, 8.9 million metric tons of milk in Asia, and then some very large amount in Africa as well? Wow, that is just a lot of milk. Who knew that goats were such an important resource? Well, Gottlieb and I are signing off, so bye for now, math students.